This is the Lone Crater YouTube. We hope this video helps.
You begin by verifying the LED panel's electrical and protocol requirements so you don't damage components. Connect the power supply, but do not power on yet. Attach ground and data wiring to the controller following pin labels. Once done, plug the controller to your PC or network and install required drivers or firmware tools. Set the IP or serial baud to the panel's spec. Make sure level shifting is applied if voltage levels differ. This gets you safe, deterministic communication before any commands are issued. You now load firmware or software that speaks the panel's protocol and map the pixel layout so addresses match physical LEDs. Once your mapping is saved, configure refresh rate and color order to prevent color swaps. Adjust gamma and global brightness to stay within power limits. Then, push a simple test sequence, single color blocks and a wipe, at low brightness to verify timing and packet integrity. If readings look good, gradually increase intensity while monitoring current and temperature so you catch issues early. You finish by deploying the final visuals, locking in schedules, and doing a final color calibration so output matches intent. Secure all connectors, add inline fuses and transient suppression to protect hardware, and save configuration backups. Run the full installation at operating brightness while monitoring for heat or artifacts. Make incremental adjustments to timing or power distribution as needed. If you encounter flicker or data dropouts, start troubleshooting by rechecking ground continuity, shortening or reterminating data cables, and ensuring the controller's buffer and refresh settings match the panel.
Thanks for watching. Consider subscribing if we helped you.